Hey, welcome to Flemdog Science. Today we're going to be looking at a combustion reaction. And as always, let me know if you have any questions that we can answer, and I'd love to work some of those out with you. So this one, we have C2H6, I think that's ethane, C2H6, and that's reacting with oxygen, O2. Now, whenever you see a carbon-hydrogen compound reacting with oxygen, you immediately want to think maybe this thing is on fire. And in this case, it is on fire. So what gets produced when we burn carbon-hydrogen compounds with oxygen? We get CO2 and H2O when you have complete combustion. When you have incomplete, we can get some other products, but complete combustion, keep it nice and simple. There we go. So how do we balance this combustion reaction? Well, first off, let's think conservation of mass. All of our carbons that were in this initial molecule of C2H6 became carbon dioxide. They all ended up right there in the CO2. All of the hydrogens that were here ended up in H2O. Because you can treat this arrow like an equal sign, and these need to actually be equal. The scales need to be balanced there. The same amount of carbons need to be on the reactant side as the product side. Currently, we have 2 carbons in this one. I can draw it for you because sometimes that helps when you're trying to figure out what's going on. Each of these lines is a hydrogen. So we can see we have 2 carbons and 1, 2, 3, 4, 5, 6 hydrogens. And then we have our oxygen, it's right here, O2. And then over here we have a CO2, which looks like this, CO2. So we can see that we had 2 carbons and now we have 1 carbon. The general rule I like to use before I really start to balance is that when you have something by itself, I like to save that towards the end, especially when it's oxygen. So we're going to balance that last. Now let's continue. This H2O right here looks like this. That's our water, H2O. 2 carbons. In order to get 2 carbons, I need this molecule 2 times. And the way that I show that is by putting a coefficient out front that says 2. That says I have 2 CO2s. And now I need to balance my hydrogens. I have 1, 2, 3, 4, 5, 6 hydrogens. And right now I have 2 hydrogens. To get to 6, I need, now I have 4 hydrogens, 1, 2, 3, 4. Now I have 6 hydrogens. So how do I show these 3 waters? I put a 3 out front. This coefficient of 3 tells me I have 3 waters. Okay, now the final one, oxygen, usually is a fun little trip to balance. Let's count them up. When you don't draw all this, the way that we would do that is we would say, I have 2 oxygens 2 times. 2 times 2 is 4, which we can see here, 1, 2, 3, 4. So we have 4 oxygens from our CO2. And on this side, we have 1 oxygen 3 times, which we can see, 1, 2, 3 oxygens. So I'll put that 3 right there, which makes for a total of 7. So whenever you have an odd number, you just get to rejoice that you get to work a little bit harder. Our goal over here is to get to 7 oxygens. 2 times what is going to be 7? And then you go, dang, there's no whole number that's going to do that, but what number will do that? Well, if you take 7 divided by 2, you get 3.5. So I think it's easiest just to put that 3.5 right there. But then you say, that doesn't look right. And it doesn't look right. So let me grab another color. I'll get blue here. What are we going to do to make this a whole number? Well, I'm going to multiply it by 2. And just like in algebra, when you multiply one thing in an equation by 2, you change the equation unless you multiply everything by 2. So I have to multiply everything by 2. I'll start with this one. I'm going to multiply this by 2, and that's going to change it to 7. That's not a great 7. 7. But I also have to multiply every other red coefficient by 2. So there's nothing here. That means it's a 1. 2 times 1 is 2. I need to multiply this by 2. 2 times 2 is 4. And I need to multiply this by 2. 3 times 2 is 6. So my final balanced equation is right here, and we double check. 2 carbons 2 times is 4 carbons, and 1 carbon 4 times is 4 carbons. That one's good. Hydrogen, 6 hydrogens 2 times is 12 hydrogens. 2 carbons 6 times, 2 hydrogens 6 times is 12 hydrogens. That one's good. And then lastly, we have 2 oxygens 7 times, that's 14 oxygens. And right here we have 8. I'll jot these down because there's going to be 2 of them. 2 times 4 is 8. And then 1 oxygen 6 times, and that is 6. 8 plus 6. I'll put another little 6 up here so we see it's different. 8 plus 6 gives us our 14, which was what we were trying to get to. So we can see this is all balanced. 2, 7, 4, and 6. Just so this doesn't confuse you, let me cross these out so you know these are our final coefficients. Hey, I hope that helps. Let me know what balancing questions you might have, and we can figure those out together. Make this chemistry journey fun and exciting. We'll do some more balancing here soon, so just check for maybe a playlist that might be there, or a video that shows up on the right. I'll see you soon.
Wonder, oh wonder.